Okay, let's start with the discussion for today. I think we are going to discuss about this paper, which is 2020 paper, and we have to discuss from the beginning. And after discussing this paper, I will give you time to complete the 2021 paper. We'll do this today as much as possible. Then let's go to the 2021 paper soon. And after that, we can discuss semi-structured and essay questions, right? So the much similar questions which was there in the 2019 paper. The theory part I won't discuss again because now I have discussed theory part. But if anything missing, yes, then I will be discussing that. So let's start doing the paper quickly without taking much of the time. And you can start answering from question number 1 to question number 4. Quickly send me the answers and then I will be discussing that now. Question number 1 to 4. Computer processor will operate fastest when data that it wants in the, so they are indirectly asking the fastest memory. So it is registers. If it is not there, so we have discussed this similar question. Okay, the register is the number 1. The answer number 2, registers. After that, it is cache memory, and after that, it is the dynamic random access memory. After that, it is a SSD hard disk or virtual memory in SSD hard disk or SSD. Then the dynamic, then HDD, normal hard disk. That is the order. We have already discussed that, and the answer is number 1. Which of the following hardware components will lose data when power of a computer is switched off? Registers is a SRAM, static random access memory. It's a volatile memory. Yes, it will erase. Cache memory is a static random access memory. It's a volatile memory. Yes, it will be erased. And main memory is dynamic random access memory. Still a volatile memory. It will also be erased. Volatile means these memories store temporary, currently processing and currently running instructions data related to that. So A, B, C are the answer for the question number 2. It is number 5, correct. Okay, the third one, question number 3. Computers had evolved from early mainframes to the relatively small smart devices with high computing power today. Which of the following inventions contributed to that? Bus is basically the transportation mechanism, nothing to do with that. Integrated circuits, yes, highly contributed because integrated circuit, very large scale integrated circuits, large scale integrated circuits, ultra large scale integrated circuit, all LSI, VLSI, ULSI all have contributed. So that is one of the main things that has contributed to the development of computing electronics and computing power, as well as it has drastically reduced the size. So this is the answer. Number 2. Registers, no. Solid state memory, those are memories, nothing to do with that. SSD has contributed, but not drastically. It's not that much. HDD and SSD is small, yes, but that is not much use, but still that is slightly correct. Vacuum tube, no, it was very large. Consider following diagram showing some bus is transportation path inside. Yeah, what is bus? Bus is a transportation path inside processor or maybe motherboard or just transportation lines. It's set of logic gates, which it is constructed with a set of logic gates and wires. Hardware part, the hardware part, the CPU indicated A is about diagrams, a set of registers that the memory has a set of registers that has a memory translation map. It is memory management unit. So memory map, translation map, all these things currently running things, that is MMU, memory management unit. So question number 4, answer is number 4. Question number 4, answer is number 4, correct. Okay, memory management unit, that is it. Cache memory is like temporary storage that is there in the processor, true, but that is not the thing that is like managing and the translation memory maps. Therefore, it's wrong. Okay. Then next set of questions. We are now expecting. We are now like increasing the speed. So question number 5 to 10 quickly. 5 to 10 quickly. Answer question number 5 to 10 quickly. Question number 5 to 10 quickly. Try to answer question number 5 to 10 quickly. Right. Consider the two binary numbers PQ. P is given, Q is given. Asking P, O, Q, P and Q. P, O, Q, O gate and AND gate. So just reminding O gate and AND gate. That's all. Just write down. This similar question was there in the previous paper also, right? So I think I don't want to discuss the theory again, but just see these similar questions. So that is the nature of Sri Lanka exams. So you are lucky. So when you do 2-3 papers correctly, then you can go for the examination and do the paper easily. But the thing is, you need to have the logical knowledge. Don't by heart the papers. කටපාඩම් කරලා බෑ paper කාඩම් කරගෙන යන්න එපා වැඩම්ම නැති වැඩක් ඒක හැබැයි papers කරලා යන්න. Okay, these are the two 1 0 1 0 0 1 1 1 0 1 0 1 1 0 0 0 1. So O gate is at least 1%, then it will display okay, at least if at least one of these 1%, it will present 1. Then this is 1, this is 1, this is 1, this is 1, this is 1 1 1 1, and it's all ones. All one for O gate. What about the AND gate? AND gate means both should be 1. Both should be 1. No, nothing. Okay. The AND result is 0 0 0 0 0 0 0 0. So that is number 4. Easy. Question number 4. Answer number 4. Then right. Then next, what is the 2's complement of decimal number minus 12? Okay, write the 12 normal way. So 2's complements. I hope that you can remember. If not, let me remind quickly. First, write 12. 12 is 1100 in binary. So the positive 12 you can write like with 8 digits. No, they're asking with 8 bits 1 2 3 4 5 6 7 8. Positive 12 is 1 2 3 4 5 6 7 8. This is plus 12, but they're asking minus 12. So when they're asking a minus number, what you need to do is you need to invert. Inverting will give you this one 1 1 1 1 0 0 1 1. But this is 1's complement. 1's complement. Once you inverted, you will get 1's complement. They are not asking 1's complement. They are asking 2's complement. 2's complement is just add 1 to this. And that is 1 1 1 1 0 1 0 0. Because 1 1 is 3. 3 plus 1 is 4. 4 is 1 0 0. 1 1 is 3. 3 plus 1 is 4. 4 is 1 0 0. So that is the answer. So answer is number 4. Answer is number 4. Okay. Right. Then question number 5, answer 4. 6 also answer 4. 7. Which of the following true about the 2's complement? An extra bit is used to represent the sign. An extra bit is used to represent the sign. No. No extra bits. Just the normal bit, but the first bit is used for the sign and makes it possible to build low-cost, high-speed hardware for arithmetic operations. Indirectly, yes. Why indirectly, yes? Because, 2's complement, no need to subtract. So subtraction hardware need not to be built. So subtraction need a lot of hardware components that need not to be built because subtraction can be done through addition. So subtraction is possible through the addition. Therefore, no additional hardware required for addition. Therefore, this is indirectly true. Indirectly means like it's not a direct, it's a direct benefit, but so because of the 2's complement, this happens. That is true. Addition and subtraction are used to do different. No, both are addition. Usually represented in hexadecimal, no, in binary. Used in the first generation computer, no, still we are using. So the partially correct or the indirectly correct answer is still 2. So I will go for number 2. 2 is the answer here. Consider the characters represented in the table A and B below, and which of the character encoding systems given below above character and which of the character encoding systems given below the above characters in table 1 and table 2 represented. You can see it's like hexadecimal. How many bits? Just count. There are 4 digits. 4 digits hexadecimal. 1 hexadecimal digit is 4 bits. 4 bit, 4 bit, 4 bit, 4 bit. There are 4 hexadecimal digits. So therefore 4, 4, 4, 4. It is 8 and then 12, 16. 16 is possible. ASCII support only 7. Unicode support 16 and 32 versions. ASCII support only 7. EBCDIC support 8 bits. Extended binary coded decimal interchange code. American Standard Code for information interchange. Unicode is unique code for everything. Like this is how a unique code is given for everything. That is basically this is Unicode, but code is not unique. That's the problem that I'm worrying. This is Unicode. Surely this should be Unicode, but the code is not unique. Oh, unique. Sorry. The B and D. My eyes. I'm really sorry. I'm a bit tired. This is D. This is B. Okay. I saw both are same. Like, no, it's unique or unique. That's unique. Okay, correct. The answer is correct. The number 2. Both are in Unicode. Because it's 16-bit and the next thing is having a unique code for that. ASCII is 7-bit, EBCDIC is 8 bits. ASCII stands for American Standard Code for Information Interchange. EBCDIC standard for Extended Binary Code, Extended Binary Coded Decimal Interchange Code. Actually, ASCII has 7-bit, EBCDIC 8 bits, but there is one called eASCII or Extended ASCII. It has 8 bits. The smaller version is BCD, Binary Coded Decimal. It is only having 4 bits, only for the numbers. Those are the methods that are used for representing characters in computers. BCD was used by old IBM machines. Then they have introduced EBCD because BCD was only for the numbers. They need a mechanism for characters. They have invented EBCD for representing characters. And then actually in parallel with that, ASCII introduced with 7 bits. 7-bit means it supported 2 to the power 7 unique characters, which is 127 unique symbols were possible in ASCII. But EBCDIC has 8 bits, so it was possible to represent 2 to the power 8, which is equal to 256 unique symbols. So both of these are okay to represent English alphabet or Latin alphabet. So both can represent that. But the problem came when they want to represent these unique, when you want to give a unique codes for Ayanu, Ana, Avanna, Ina, Ivanna. So those things, and maybe in Hindi, Tamil, Chinese, Mandarin, or this Pinyin, whatever the Chinese charactering system, the phonetics, and then likewise Japanese. All these, how can we represent? Then people were searching for a solution. The unique code came, that is Unicode. Unicode has 16 bits, so 2 to the power 16. 2 to the power 16 is equal to, what is the amount? How many unique symbols when there are 16 bits? The unique symbols is 2 to the power 10 is 1024. Then 10, then 11 is 2048. 12 is 4000 somewhat. 13 is 8000. Then 14 is 16,000, around 16,000 some number. Then 15 is 32,000 some number, and then the 16 is 65,536 as I remember. So that number of characters, so it was enough to represent other languages too. That is why the Unicode came. But there's another version of UTF. UTF-16 is basically Unicode 16-bit version, and there's another one that is 32-bit Unicode. That is a big Indian Unicode, or 32-bit. That is a very large number of unique symbols because they are in the 32-bit Unicode. Okay, that lesson is done. That is actually a lesson. This is like 2 period lesson. We have finished that. So if you are in a theory class also, you will do, but not this way. We will do some exercises, but here that theory was done. So answer is number 2. Let's go for the number 9. Which of the following is most simplified expression of ABC, and this one? So you have to simplify either using K-maps, or you can use Karnaugh maps, or the other version is like you can solve using the Boolean algebra expressions. Anyway, once you solve this equation, so how you can solve this? You have to take the common things out. That is the easiest way of solving this. So let's take the common things out and try to solve this very quickly. That is inverse of the distributive law. You can see here BC naught, AC naught is common for this, and I'm taking AC naught out. Then what is in the brackets? You can see B naught and B naught OB. B naught OB is in the brackets after getting AC naught out, and then the next thing you can take C. No problem. C you can take common thing, but B you cannot take. Okay, let's use that. Is there any other way of doing that? No. A not B, no, that is also not a solution. BC not BC, that is easy, but again from that the B will remain. Okay, let's take C out anyway. There's no other way. So A naught, B naught, and B will be here. Right. So this B naught is 1. This again, so you can use with AC. Then the identity law will make it AC naught, and then here C is there. Then you have A naught, B naught, or B. So let's use a distribution law to this one, and that will distribute this AC naught. You can write this as B, or sorry, C is outside, then B, or let's bracket it again, A naught and C, A naught and B naught. You can write something like this. Then you can distribute B or with both. That will give you AC naught, and then C. Then B is distributed with that B or A, B or sorry, B O A will be here, B O A naught will be here, and then the other one is B O B naught, B O B naught, B O B naught, because B naught is distributed to both. B naught is distributed to this one. So then you know B naught, B or B naught is 1. So this one and this one will be the same. So you can write A C naught, C here, and then 1 and this will be B and A naught. So let's redistribute back using the distributive law, and that will make A C naught, C A naught C, and here you have BC, AC naught, AC naught, KC naught, B, B, C, A not C. How to remove the C? Did I do something wrong there? C is common here, C is common here means, okay, do we have answer there? So what are the answers? Any close answer? A, C not, A not, C is there in the fourth answer. But B is isolated. So what we have done here, okay, let me check again. A, C not, B, A, C not taken, B not, B. Okay, that will solve and remove that. A, then here C is taken. A not B is A not B not B is there. The B is taken, B is distributed. B is distributed to both, so this will make like B or A not and B or B not. B or B not is 1. B or B not is 1, and this is remaining. So CB and CA not. BC is here. Okay, let's do something. Let's add another one more term. Actually, in this place, right? We can rewrite these statements. We can remove that, but in order to that, we have to rewrite the statement A, B not C, A, B not C not. Oh, so maybe I have done some mistake in solving that. I'm not going to discover that, but so I'll try with the answer number 4, which is closely matching with my answer. B, C not, I can generate that. So then A not, B not, C, and BC. And actually, I can again add BC not. Why? I can again add BC not to this because you know the idempotent law AOA is A, right? So if I add two of this, that doesn't matter. This one, I can, if I duplicate this, that doesn't matter, right? If I duplicate this, that doesn't matter. The reason is because AOA not A according to idempotent law, so I can have a duplicate of this one. So that will propagate. Now, actually, I'm taking this one and then BC not, actually these two together. Okay. Then I'm taking these two together. Okay. After that, this will remain. This remaining BC not will be here, 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 here. All these places it will come, and here also it's there, and here also it's there. So I can bring it down, right? BC not, I can bring it down. So then you can solve this. How? You can take B out, then you can write C not. So C not is C not is 1, so it will isolate B there. So then you can get the answer A not C, and O B. So answer number 4. Maybe I have done mistake in solving, that is why it was not solved at one go. So sometimes this can happen to you. So go for the closest answer there. There should be an isolated B. So yes, initially if you isolated B here, make a solve karana. If you solve this one initially, yes, that will do the work, right? If you solve this one first, that will do the work. Yes, that is true. 10th question is about this block diagram, the sequential logics shown below. Sequential logic is basically memory circuit. Memory circuit. Sequential logic is a memory circuit where the current input, normally what we'll do in the combination logic, current input will decide the current outputs. Then in output take a labeling. That is the memory circuits. That is the combinational circuits. Adders, those are combinational circuits. Current input will decide the current output. But the sequential circuits can memorize. It can keep and hold the input for some time, and the next input and this previous input will mix. So this is used for forming memories. Okay. Block A is a combinational logic circuit. Okay. You can use one current input, current output. It's a combination, agree. The block B is block A is a combination logic circuit. Block B is a memory element. Yeah, that is also okay. Block A is a combination. Block B is, yes, block B is memory element. It's a circuit like this. Only block A can be implemented using logic case. So both can be implemented. So only 1, 2 are correct. 1, 2 are correct means answer is number 1, 2 correct. Yeah, only 1, 2, number 3. Okay. Again, logic gates. You can see how influential this logic gate lesson is, right? There will be a lot of questions from the logic gate. Today we have discussed logic gate part in our theory class. What is it? A sequential circuits. This circuit is a sequential circuit. That is true. Fully taken, this is a sequential, but it has a combinational and sequential both. Okay, consider you can go from question number 11 to 15. Quickly, 11 to 15. Good. We are doing up to 17 even. It's very good. Okay, considering following logic circuit using considering only the NAND gate, the required output of the above circuit, then what should be the input for X and Y? You need to generate A, B, A naught, B naught, C naught. A, B, A and B. A and B is here. Then A naught, B naught, A naught, B naught. Then C naught. Okay, C naught. So you have to you have to think about like the asking X and Y. So first of all, let's put this into the let's write a statement. A, the first one will give A and B, everything not. The second one will give A naught, X, A naught and X, everything not. The third will give just Y. This will be ANDed, right? The third will give Y. Third will give Y. Okay, then this will be ANDed and again not. There will be again a not applied to this one. Not applied to the this one. And then this not you can share with these things. So you know the individual nots will apply because of the De Morgan's law. What will happen to this statement? When you remove this part, you can apply Y not there, and here will be this one not, and this one also, this one not, and the middle sign will be changed to O. That is by applying the De Morgan's law. Okay, so this is AB now, and this is A naught, x now, and the next is y naught. Okay, so what is the expectation now? In order to get y naught, so you need here c. If there is c, you will get c naught. In order to get a naught, b naught, a naught is there, but x has come, it is not b naught. Then you have to feed some not there, that is actually b, that is actually a naught x should be a naught b naught. In order to make a naught b naught, this should be b naught. So x is b naught and x is b naught and y is c. So answer is number 3. X is b naught, y naught, that is 3. The answer is number 3. That is for question number 11. 12. The operating system is another program that can run on a computer that has some special responsibilities like memory management, file management, input-output management, some of these responsibilities. What is the important responsibility of operating system? They are asking. Backup management, no, not that task is that much important. Cache memory management is also part of a memory management. Compiler management, no, OS is not really doing that task. Process management, of course, yes, it's very good, like important role of the OS. System clock management, this is more important. So let's go for the answer number 4. When the number of processors started and use a single processor computer increases, what happened to the resource time each process as pursued by the end user, the memory management related to work of the operating system respectively? Response time will increase because it is a single processing computer, single processor. When you load new task, the response time will definitely increase. And what about the memory management related work? Yes, that will also increase. Both response time and the memory management related work increase. 13, number 1 is the answer. Which of the following is not a responsibility of operating system? Not a responsibility. Allocating physical memory to process, it is a responsibility of operating system. Deciding which process to run, yes, process management, that is task of operating system. Number 3, keeping track of the usage of compiled programs. No, that is not a task. No need to do that. OS is not responsible for that. Keeping track with the parts of the memory. No, yes, which are free, which are used, yes, need to do. Swapping process between the physical memory and swapping and paging, yes, that is also part of operating system. But this one, keeping track of the compiled program, no need to do. 14, number 3 is the answer. 15. In a computer, the size of... Meanwhile, you can ask the question number 16. Sorry, if you are not done, please answer. Question number 16. In a computer, the size of program could exceed the size of physical memory. Also, only the demanded areas of the program keep them physical memory. That is called paging, right? That is basically the paging. They are asking about that because the paging is similar to the book pages, because you are not going to read the entire book once, but you read page by page. Similar to that in computer also. So they will keep page by page, they will use page by page and manage. So that is the nature. It's not going to take entire program into the memory. Let's say Photoshop is 3 GB. It's not loading all 3 GB into the memory. It will load most important parts as well as the working parts. Others, it can later take. So when it is needed, on demand, when it is needed, the pages are taken. So that is basically using the pages and the page management system and the frames and the page tables. All these are coming. And number 5, the number 5 is the answer. Question number 16. Which of the following statement regarding compilers and interpreters are correct? The compiler transforms entire programs into the machine code. Very true. It does that. An interpreter converts the high-level program statement into the relevant machine code during the interpreter convert each high level. Yes, interpreter converts state by statement. Compiler translate all at once. That is very true. Compiler translate all at once. Interpreter translate one by one. Compile code usually run faster than interpret code. Yes, compile is very fast because it is compiled at once and very fast, and you can say all A, B, C are correct answers for question number 16. Hope I'm not too fast, right? Not well, but I'll try to manage, at least try to finish half of the paper, right? Because now we need to do this a little faster. 17 to 22, please. 23. 17 to 23. So please provide your answers. Good that all of you are now sending the answers. That is something to be happy. All of you are trying and sending the answers. That is good thing, good trend. Okay. Let's see. Let's check. You can reach. You can also recheck. I'm not telling your individual answers. That is like it's not good. But I know who are performing, and I know how to support you. And so sometimes you are struggling. I know those things also. So let me support. You like it's very easy. Like now I feel confident about yourself because I have taught you for some duration. I taught you, and now you are taking the advantage of that. And also you have done very, actually not, it's not me, I just guided. You have done a great job. Now you actually understood the lesson. I guess that you understood it, right? Okay, that is the your duty, and you have done that in, so it's self-control, nothing. Because no, you know, I know that's a very difficult to keep students in keep at least 1 or 2 students in a online environment class, because like your focus is basically with your age, your focus is to move out, hang out with the friends, and do something chill, like chilling, do something enjoyable in during your A-level time period. It's a very difficult thing to concentrate and be in front of a machine listening to a lesson. So I know that how difficult that is. Therefore, so it's very difficult to retain students and actually keep the focus and improve them in online environment. But I have proven and I have done this for a long time. So I'm happy about that. You are getting the benefits of that. I hope my classes are not that much boring, where it will make you sleep after some maybe 2-3 minutes. At least you can wake up for 1 hour. That is good, right? Which of the following statement regarding the guided unguided media correct? Guided media transmission support higher data speed. Yes, of course. The reason is because unguided media is affected by a lot of factors like weather, climate and all, but the guided media is not. So basically guided media has more data rates than the unguided media. So that is true. So I agree with that. Asking what? Which are the true statements, right? Guided media is subjected to less interfere than unguided media. Guided media is subjected to less interference. Yes, basically less interference than, that is why the data rate is also high. Then unguided media transmission more secure than the guided media. No, guided is more secure. C is incorrect. Guided media, unguided media transmission uses less bandwidth than the guided media. Unguided media transmission uses low bandwidth than the, yes, guided media, the bandwidth is high. Bandwidth is basically gap between the lowest and highest frequencies. So that is, so let's take it simple. Bandwidth is basically if there's a pipe, the amount of water coming through the pipe in a given time. So let's make it easy. So anyway, the bandwidth of this, you are reaching higher bandwidth with guided media. So unguided media is less bandwidth. So A, B, and D are correct. We can select answer number 2, 17. 18. What is the process carried out in modulation technique, the data transmission? Modulating is basically you have like less powerful signal, and you are merging that, or you are mixing that with a high powerful or high frequency signal to transmit it for a very long duration, very long distance. The reason is if the signal power is less, it will attenuate. It will basically attenuate means the strength will go down. So for an example, think about our voice. We cannot talk to a few kilometers. No, we can only talk for a few meters, maybe maximum 100 meters, 200 meters. We can talk in a normal tone. So that will not propagate the tone, or the voice will attenuate. So if you mix it with frequency, mix it with high frequency and send it, then it's like FM transmission. So then even radio you can hear from another country also. That is basically encoding data, right? Encoding information, okay, encoding information in transmitted signal. Encoding signals in encoding information, encoding data or information from the encoding signal from extracting, extracting is wrong word, encoding is correct word. So information in the transmitted signal, okay, one is correct. 19. Which of the following statement about the bus topology is incorrect? Bus topology is connecting like bus stops, right? Single baseline, the connected using T connectors. It's like bus stops. Computers network are connected to single cable. That is true. But they are asking what is incorrect. Yes, yeah. What is incorrect? It's connected to the single cable using T connectors. That is true. But they are asking what is incorrect, right? All traffic flow either clockwise, anti-clockwise. No, it's not a ring topology. No, ring topology is sending clockwise, anti-clockwise. But this is no. So B is incorrect. So they're asking incorrect answer. No, so where you can see the B. This one B is no, we cannot select. B is there, and B is either 1, 3, or 4. 4 is correct answer, right? Bandwidth is shared among the nodes. Yes, because it's a baseline. The bandwidth frequency range will be it's like bandwidth is like, let's say, water supply. If there's a single line of water supply, everyone need to share that supply. That is true, right? So simply let's make it simple. So each node is connected to 2 of its neighbors. Each node is connected to 2 of its neighbors. No, it's in ring topology again. Ring topology, there is like right side and left side, there are 2 nodes. But in bus topology, it's not. So it can be 1 or 2, or it can be many. It depends, right? So here it's B and D are incorrect. Therefore, 19, we can take 4 as the incorrect answer set. That is the correct answer here. 20. Consider the following statement with a bank, a media access control MAC. You know, the MAC address is basically the physical address. If you want to see your MAC address, you can type ipconfig all and it will show you the MAC address of your computer. Here in the Mac or in Mac or Linux, it is ifconfig. /a. Oh, it's not access. Okay, here you can see the physical address. Okay, the easy way is you can use ARP, address resolution protocol, ARP -A, and you can see the correspondent IP address and the physical address of that. Then this IP address is basically 32-bit 4-portion dotted binary number. Then 4-portion 32-bit 4-portion dotted binary number. So that is the definition of IP version 4. IP version 6 is 128-bit one, and this MAC address is physical address. It's having here, you can see how many digits: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 hexadecimal digit. 12 into 4 is 48 bits. 48 bits physical address. So physical address basically is we consider that as not changeable. It's unique device. It's unique to the device. That is how we consider, but it's not really like it's not really read-only, it can be edited, but under the normal considerations, it's not editable, right? So what is here? Which of the following is suitable to fill the blanks? Usually represented in what hexadecimal numbers, right? So you saw that it's usually represented in hexadecimal numbers. Question number 20, answer is number 3. Here you saw the IP. This is in decimal and this is in hexadecimal. ARP is address resolution protocol, basically converting your IP address to the physical address. What is happening there? When a new computer joins, it says it only has the physical address now. It will broadcast a message to everyone saying, hey, I joined, I need a logical address or IP address to join. Then, so if there is a DHCP, if there's a DHCP or dynamic host configuration protocol, DHCP server in your network, that server replies, hey, keep this address. Then the correspondent person, the correspondent machine which has sent the ARP request will get a reverse ARP, reverse address resolution protocol, RARP resolution. And with that, it will be assigned IP address with the support of DHCP, dynamic host configuration protocol. DHCP support will, that is where DHCP presents. But when DHCP is not there, you have to manually assign IP address. Normally, for this Wi-Fi networks and all, when you join, it will auto-assign IP address because DHCP is present. Actually, it will send you a physical address and asking for the IP address. That is this ARP protocol. That is why when you type ARP-A, you can get the details of your physical and logical address mapping. Right? How this physical logical address mapped, you can get the details. Routers MAC address, then the computer's MAC address, routing switches MAC address, likewise the device MAC address can be. You can type this in your command line, ARP-A, and get your details too. Okay, then what you are requested to create a 16 subnet with class C. I have recently done this networking class and it's there in my YouTube channel also, but some of the lessons are not there. So, but essential parts are there. You can just refer. If you need further assistance, you have to contact me and I will just, if you need individual support, can be done. But some of the content are there in the channel too. It's up to you to refer and learn. And if you need a support, you can, yes, it's possible to give, but you have to ask because this part is big technical, right? I cannot explain, I can explain this in the class, but it will take some more time. Today, my idea is like, my aim is to finish at least 25 questions. That is why I was just hurry in completing this. Okay, 16 subnet with class C IP. So then asking the suitable subnet mask. 16 subnets with class C IP. Okay, 16 subnets. When you need 16 subnets, means the bits allocated need to be 4. So 1, 2, 3, 4, 5, 6, 7, 8 need to be, this is first octet. Okay, the second octet. 1, 2, 3, 4, 5, 6, 7, 8. The third octet, 1, 2, 3, 4, 5, 6, 7, 8. Because class C IP, no, you have to keep this class C subnet mask, which is 255, 255, 255. From the remaining bits, you have to get at least 4. Why? 2 to the power 4 is 16. You have to get at least 4 and remaining bits you can keep 0. This 4 will introduce 2 to the power 4. 2 to the power 4 unique networks. Okay, 4 balak networks introduce karno sub networks. So okay, now translate this to decimal. This is 255. This is 255. This is also 255. The next one is what? This is 128 plus 64, 192. 192 plus 192 plus 32. 192 plus 32 is 224. 224 plus 16 is 240. This 255, 255, 255, 240 is the correct one. That is number 1. So the subnetting part, if you have doubts, I can explain this next day. Don't worry. The question number 21, answer is number 1. If you have any doubts on the subnetting part, I'll explain in the next day, right? Then let's go for the 22, 23 questions. 22 and 23. Question number 22 and 23. So it's okay to answer the future questions, but thing is, give your focus to the current questions also. Otherwise, what will happen? Otherwise, you're in trouble, right? So listen carefully. Then it's okay. You can answer the future questions. That doesn't matter. But make sure you are answering current questions also. And focusing on current questions too. Which of the following statement regarding the testing of a system are correct? Black box testing is involve detailed checking of the each line. No, never. Black box is, black box is something like this where you cannot see what is inside. You are just putting the expected inputs and you are expecting outputs in expected way. You don't know what is inside. You are not checking it. That is black box, completely black. Unit testing helps to uncover errors in the code. Yes, unit by unit, you are checking the code errors too. This is true. This is true. But this is not true. System testing should not be performed prior to unit testing. No such rule actually, but better. We cannot guide, we cannot actually restrict that by a rule. Should not be done. So yes, actually, system prior, and sometimes we need to do your system testing also. But at least before that, at least 1 or 2 unit testing need to be done. But considering that, we'll consider that as an answer. For 22, let's go for BC, and it is answer 5. But that is not a very good selection, very good statement. Which of the following indicate, because aim of this paper is not to answer this paper, right? You have to remember that. I'm telling this again if you are new to the class. Aim of answering this paper is not to answer this paper. Then what? මේ අපි කරන්නේ මේ paper එකට උත්තර ලියන්න ඉගෙන ගන්නව නෙවෙයි. මේකට උත්තර ලියන්න ඉගෙන ගන්න එපා. You go and download the marking scheme and mark the answers. Right? මේකට මේ paper එක ඔයාලට මේ 2022 23 එන්නේ නැහැ. This will never come in 2022 or 23. එතකොට මේ paper එකට උත්තර ලියන එක නෙවෙයි මේ aim එක. That is not the target. By referring this paper, answering the next paper is the target. By referring, this is a reference. This is just a benchmark to see how the questions are coming and to check your knowledge. That is why the answers are important. Yes, answers are important, but answers to this paper is already published. You can download it. But that is not the main goal. The main goal is to answer future question papers. Therefore, argue. That's why I argue. So answer C is a system testing should not be done performed prior to unit testing. Just you can think this as a okay, correct, because unit testing, then the integrated testing, then the system testing. That is the practice, but it's not a rule. So if you need, you can do the unit testing first. But what happened? They cannot argue. So I did unit testing, I did system testing. And I'm confident about the unit, so I did the system testing. So can be done because there are different ways. Top-down approaches are there, bottom-up approaches are there. So the bottom-up approach, yes, unit testing is first, but the top-down approach, sometimes you start doing system testing and dig it. Right? Sometimes these top-down approaches are also applied in some kind of developments. Okay, that is why I argued, because in future question paper, sometimes this might not be the answer. So here you have B and C, but let's see you don't have something called B and C, then you have to go for B only. That's it. Okay. Which of the following indicate the functional requirement? Functional requirements are the main requirement. User should be allowed to update the contact address and phone numbers. That is compulsory. The user should be allowed to update the contact address. Yes, that is a compulsory requirement. Any user request must be responded. That is a restriction. We learned this few times, right? If it is directly a need, it is functional. If it is restriction on a particular functional requirement, that is non-functional. Any user request must be responded within 2 milliseconds. That is a restriction. It's a non-functional. The system must be easy to change. That is also casual, easy to change. That is a restriction on that. So A only is the answer of question number 23. Okay, 2 more questions to go. Let's complete this. At least half of the paper is done. So because we have to speed up ourselves now, actually we are doing this with the discussion. So I think our rate is okay because we have taken 1.5 hours, 1.5 hours to discuss up to question 20, to discuss 25 questions. In your real exam, without the discussion, you have to answer 50 questions. I think our timing is okay. I think our timing is okay because we have time to discuss and also discuss the theory, everything we have time. That means like you can answer 25 questions easily, sorry, not 25, 50 questions easily within 2 hours. 24, 25, 50. The following details are given about the software project. The requirements are fixed, not allowed to change throughout the complete project. Should be waterfall, right? Okay. Must win because when this statement is there, you can predict the answer, but let's see. Still, we are too early. Then must deliver the complete software product at once. Yes, that is now confirmed. Detailed description and specification must be prepared every activity within the project. Yes, that is waterfall. Confirm. So the features of the waterfall, when requirements are fixed, not changing, when it is need to be done step by step, when you cannot go back to the previous stage, when the system is finally delivered at the last stage, that is waterfall. 2. Sorry, 5 is the answer. Which of the following is incorrect about DFD? Context diagram is DFD, the highest level of abstraction. Yes, context diagram is the summarized level. It is system level representation. It is highest. All data stores in the system must be represented in the context diagram. No, it's as a system. No need to display all the data stores. Then data flows are used to link each other components in DFDs. Data flows are used to link each other components in DFD. Elementary processes are not decomposed. Elementary is the last leaves. Elementary at the leaf end. So we are not further dividing these elementary processes. External entities in DFD act as source or recipients of data. Yes, external entities. This is how the system deal. External entities are acting as data sources or acting as data recipients. Or that is true. They're asking incorrect one. Incorrect one is this one, right? All data stores need to be represented in context diagram. No, it's not. So that is number 2. Okay, I think we can discuss the remaining part next day. I think we can finish the syllabus or finish this also. Next day we will finish this, and then we will start what? We will start 2021 pay, and after that we have time to discuss the essay and structured and essay part. That will conclude the discussion, and then it's your time, and you have to show your performances. Okay, then good night. See you all next week.
Thank you, sir.
Thank you, sir.
Right.